Hello everybody, this is Todd Frazee, and this is the S60-119 Cam tutorial for the secondary piston for HSM Works. Okay, this is a similar feature to other parts we've done. It has a slot with a through hole. These holes are for press fit for a 16th pin, and it's going to be a turned and milled project. Alright, so let's go to our model, and we should have already by this point modeled cut the dash 105, which has some similar features in it, uses some similar tools. So we're going to copy over some of the work we did from that project and then modify those toolpaths. Okay, so we have all our lathe ops, okay, and we have all our turning ops in the 105 file. I'm going to right click, we're going to go copy, we're going to go over to the 119 file, we're going to go paste, and then we're going to go back and do the same thing for the mill ops. Copy, paste. Now there's some things we're going to have to change, but now that we've done that, we want to save everything, both files, and then we can exit out of the dash 105. Alright, so we need to also, this has an interrupted cut on the turning for the area with the slot and the hole in it. So HSM will choke on some of the machining operations. So what we want to do, before we set up our stock to redo the setups or job folders, we need to make a sketch visible so that we can use that for turning. So we're going to go back to our revolve sketch. Should look something like this, and we're going to right click on it and make it shown or visible. And the reason we need this visible now is we're going to set up our origin, and it has to be an orientation to this. So we're going to use this outside line. We're going to regenerate the toolpath we used on the other part to make this one. Okay, so we go back to Cam. Okay, let's focus on the turning first. We're going to go Edit. And yes, we know the geometry is no longer valid. That's why there's all these X's. We're going to regenerate it. We know that, so we're just going to keep hitting yes there. Okay, so we're turning this part, and we need to first change the name, because it's not the 105 anymore. It's the 119. Okay, and we want cylindrical stock, but we want our orientation to be in line with this model. And we're going to scroll down to our origin. It's not pointing the right way. So we're going to go Z-axis and X-axis. Select on the face. Now it's pointing the correct way. Okay, now our diameter on this part is not the same. We're using 1/4 inch stock, but we need to change the radial offset. So it's 0.25 minus 0.157, and we're going to divide all that by 2. Which gives us our new offset. There's just more material to remove off this part than there was off the last part we did. Okay, and with our origin placement, I picked the face, but you need to make sure that X is in the same axis as your sketch, in the same plane. If it's not, you need to reorientate the X axis so it's in the same plane of this as this sketch, so we can use that effectively. We got the 119 op 1. We're going to go down here. We're going to change this to 119.1 is our program number, and we need to change this one to 119. Otherwise we're gonna run the wrong part, wrong program. Okay. Okay, we're gonna accept that. Okay, now we can start regenerating toolpath. So we're gonna take and right click on the facing operation. Go edit. Okay, so here's where, because of our interrupted cut in that plane, it thinks that it's cutting it, facing it off way back here, which would cut off part of our part. We need to hit model, and we need to select our geometry that was at the front of the part. And then that puts it where it's supposed to be. And that was the whole reason we made that sketch visible, so we have the option to select on those things. Okay, our lead ins and lead outs the same as we had set it. We're going to go to diameters. Yeah, so we want to go from stock OD to stock OD to model ID, and we want to go another 10 thousandths deeper, which it's done. Then go to the next tab. We're going to leave all at default. Next tab, leave it all at default. Okay, so we've regenerated the first toolpath. Other program, we were drilling the end. We don't need to do that. So we can delete. Okay. And now we're going to turn the outside of the part. So we're going to right click, we're going to edit. Okay, so we're going to update our turning profile, and we're going to go now. I want to warn you, the first time I did this, Solid Works crashed on me. So make sure you're saving a lot, and I don't know, third time so far it's running. So we're no longer going to select this line that was from the other model. That might have been the issue. And you notice it's only selecting the fully enclosed part of the model as it's turning because of this slot here, just like it did on the facing. So we're going to select geometry instead, and that's from the sketch. And so it's going to ignore the model and should just cut that. Now we had a 200 thousandths tangential extension on the end. We don't need that much anymore because the other one was taking off more material. So we're going to go 0.18 instead of 0.2, a little bit shorter. And then we're going to go on to the next tab. And all of this should be going from, we're going from the stock OD, which is true. Outer radius to stock OD. The inner radius is not the model OD. It's actually smaller than that. It's this radius. So we're going to change that to selection, which gives it the cylinder of the smallest cut. Alright, we're going to go on to the next tab, and I believe we're going to leave all this at default. And the following tab, we'll leave that at default as well. Let's see what happens. Alright, so we have our, looks like we got 2 roughing cuts and then a finish cut. Yeah, it looks reasonably well to me, so we're good there. So again, make sure you're saving a lot. Okay, now we're going to go to the turning part. Right click on that. We're going to edit. And it should be cutting the back side of the model. It looks like that one is working without having to select the sketch. You can see the blue highlighted zone. Okay. We do have to make some changes here though. So on geometry we're fine. On the diameters we're fine. On the next tab on the other part we left stock to leave for another cutter to take off. We're not doing that in this case because we don't need to cut this. That's a finished face. So we're going to deselect the stock to leave tab. Then we're going to go to the next tab and we're going to leave that at default. There we go. We've now just regenerated everything we need for turning for this part. Now let's go on to the milling tab. Okay, so in our other part, we were contouring the end. We don't need that because it had an arc on it. This one doesn't. It's already cut the finished size. And then we were cutting a tang. And in this case, we're not cutting a tang, we're cutting a slot. So we don't need all three of these. In fact, we're going to delete the first toolpath. Now I forgot to do one thing. I'm going to just change the description. So both these. Reflect the part number. Okay, and now we need to set up our milling operation. So we're going to go edit. Yes, we know we have geometry that needs to change. We're still doing milling. It's the 119. Op 2 for the mill. It is cylindrical. We're going to select the cylinder of the piece. We're going to have 0 on our backside offset. Okay, so our z-axis, x-axis is going to be one of the flat planes that makes up the slot. And then we want to put our x-axis reference in line with the center line of the part. And that needs to be reversed if we're looking at it in this orientation. And we're going to go with middle side 4, which would be the left side of the part. And that way, if we have a collet stop, we can slide the cylinder in. It'll butt up against that as our origin. Okay, scrolling down, we're going to change our program number to 119.2. And our part number to 119. That job should be set up the way we need it. Make sure you're saving. And there were 3 contours I copied over. We're only going to use one of them. So let's delete all but one contour, and this is for the saw. If you got a different one, that's fine. We're going to change all the parameters. But as long as it's one of the contours that does the slot milling. So we had actually 4 contours. We had an end mill coming in and cutting an arc. And then we had several contours doing the saw, but we should be able to accomplish this in one routine. So I'm going to go edit, and all this is going to stay at default. We're going to go to geometry. Okay, we need to select our edge, and it's going to be the edge there. And you need to have propagate along Z deselected. And we should have the carryover of the tangential extension of 625 thousandths on this line. That's for half the diameter. But we need to make sure we add more to the lead in, because this line is actually shorter than the distance of the material being removed. We do need to add it here, otherwise it may not necessarily be a straight line. Okay, so let's go to evaluate, and we can measure between a vertex here and the endpoint. Yeah, it looks like it's about 100, it's about 10 thousandths more. So let's go ahead and bump this up to, we're going to actually bump it up 20. So let's go 645 thousandths. And that way we'll be sure that we're cutting a straight line when it engages that. Okay, we're going to go to heights. And we do need to change some things here. We are going from stock top, that's fine, stock bottom, and we're going right to the contour. If you don't have 0 here, you need to change that to be 0. So in the depths tab, we're going to go from this edge to the top, bottom of the slot. So our top is actually not stock top, it's going to be from selection. And we're going to pick on the other side of our tab. And we'll go to the next tab. We're going to leave a lot of this the same. And we're going to do one finish pass, and it's going to be the difference between the cutter thickness and our slot width. So if we're going with a 0.0, so you need to put in whatever the slot size you modeled your part at, but I did 0.0705, and I'm going to subtract a 16th, which is 0.0625. And that'll give me 8 thousandths. And what that'll do is it'll make the slot at nominal in our program halfway between 73 thousandths and 68 thousandths. Okay, so we're going to set our multiple depths, and we're going to put in the thickness of our cutter, because we want to force it to only have one rough cut and one finish cut. And that finish cut is going to be at 8 thousandths. And we need to do it at every depth with a saw. Okay, let's move on to the next tab. And here we can keep everything at default from our copied toolpath. Okay, we have our toolpath coming through here. We should have one rough cut, one finish cut, and they're 8 thousandths apart. And that should cut the slot right to its nominal size. We can make adjustments for there based on conditions. Okay, so now what do we have? We have a couple drilling operations. Now you notice the drilling operations are going in the way we have them ordered right now, are going to put pressure on this area where we've already cut out a slot. Sequence wise, I don't think that's such a good idea. This is a small part. We cut the slot, we hit this with a series of drills, and we're most likely going to smash this top piece down a little bit so it pinches in between. So I'd rather do those holes as all the way through without an interruption. And so we're going to change the order of operations to move the slot at the end. Okay, and now we can go and regenerate these drills. Now the first drill is a spot drill, and since we're doing this on a curvature, we're not going to realistically get chamfer one. It's going to look like an oval if we attempt that. So we may need to adjust those settings. So yes, we need to regenerate, and we're going to skip the first tab. We're going to go to the next tab, and we're going to select the hole we're drilling. Okay, it's just the first one there. And then we're going to go to the next tab. Yeah, we're just going to set the depth on here to negative half the diameter. So our finished diameter after its ream is 64 thousandths, 0.064 divided by 2. Okay. And then we'll leave the rest of this at default. And then we go to the next tab, and we should be able to leave that as is. It's our spot drill. Oop, made a mistake. It was supposed to be negative. Negative 0.032. There we go. We should get a slight spot there. Okay, now on the deep drilling, we're using the same drill bit that precede the reamer, but the reamer is going to change. So we're going to go Edit. Yes, we want to modify this. And the first tab stays the same. Second tab, we need to select both holes in this case. And then we need to check the auto merging hole segments. That way it does them all as one drill operation and not two separate ones. And we're going to go to the next tab. And pretty much all of these parameters should be fine. We're going from the top of the hole to the bottom hole, and we're going to break through with the tip, and we're going to go an extra 10 thousandths. So we'll just accept that. And we're going to keep our pec drills at the height we had them, and we'll accept that. So now we have our drilling that precedes the reamer. And now we're going to go to the reaming operation and go to Edit. And we need to change tools. This is the press fit side, so our diameter was actually 60. So we need the 60 thou reamer or whatever's closest to that. Okay, so we're looking for you're looking in the Mill Tools library, and we're looking for the reamer that we're using for press fit. And it looks like it's the number 53 reamer. So we select that reamer. It's just changing the size of the reamer needed for this operation. Our cutting feed rates, we need to slow this down. 10 inches a minute on all of those. Okay, for geometry, again, we're going to select both holes, and we're going to auto merge the hole segments. Go to the next tab. We should pretty much be able to keep this all at default, and then we're done. Okay, so barring any crashes, that should be pretty straightforward, and we've now programmed the -119. Okay, we're going to move on to the next part, which we'll be able to recycle code from this file and the previous one we did, the -105, because there are similar features and hole patterns on both. So it should go quicker.